Hey, what's up everyone? If we haven't met before, I'm Alissa Knight, Chief Evangelist for Deepfence. Deepfence provides observability and security for your applications from development to production with two separate solutions, ThreatMapper and ThreatStryker. Believe it or not, ThreatMapper is completely free as an open source security solution that enables you to perform multi-cloud vulnerability scanning, attack surface mapping, and prioritization of vulnerabilities running in your containers, images, hosts, and repos. Now this includes cloud workloads, Kubernetes, even serverless, and is 100% free. For enterprise users, Deepfence also has a tool called ThreatStryker, which provides runtime attack analysis, threat assessment, and targeted protection for your infrastructure and applications. Now, unlike ThreatMapper, ThreatStryker performs deep packet inspection of network traffic, system, and application behavior, alerting to suspicious events happening within the observed network traffic. ThreatStryker extends ThreatMapper with a real-time correlation engine that matches the threat map with real-time telemetry and is able to identify attacks in progress, then deploy mitigations automatically to neutralize attacks and prevent lateral movement. Okay, so for those of you who still don't understand what ThreatMapper and ThreatStryker do, here it is in plain English. Deepfence's tools detect and prevent lateral movement, malware, vulnerabilities, hard-coded secrets misconfigurations, and application and system behavior anomalies of your serverless and cloud workloads. So what exactly does this mean to you? It lowers the overall mean time to detection and mean time to response, lowers the dwell time of adversaries, detects attacks in progress, identifies mistakes made by developers, prioritizes and ranks vulnerabilities for developers for prioritized remediation. In short, Deepfence provides runtime protection, vulnerability management, and security observability for the cloud-native enterprise. Okay, so now that I've thoroughly explained all of that and you hopefully get exactly what it is both ThreatStryker and ThreatMapper do, are you ready to see it? Come along with me as we finally get visibility into what's happening in your cloud workloads. The first thing you're going to see is this sort of hierarchical view of all of your cloud service providers, directional arrows as far as where traffic can go, either egress or ingress, what's reachable from the internet, what can reach the internet, that sort of thing. So here we're logged in. I'm going to go over the dashboard starting from the top. So again, this is your topology view. You can search your topology for specific keywords. Right now we're at the cloud view. From the last 30 days, we can go ahead and change that to the last 60 days, 90 days, last 6 months. So I'm going to go ahead and set that to show all. And then we can change the cadence of the refresh. So by default, it's going to be set to 30 seconds. We can change that all the way up to 1 day. So I'll leave that at 30 seconds at the default view. This is going to count up the number of cloud providers within our infrastructure, within our system, which contains 19 containers, 28 container images, 5 hosts, 1 Kubernetes environment, 3 namespaces, and 6 pods. And of course, this is going to allow you to sign out or go directly into settings. Now, for those of you who don't really like the graph view, there is an option to actually pull up a table view. So you can create a new view here and actually pull up and look at everything by cloud service provider in a table. And on the right hand side, this window that you saw pop up over here, that's just going to give you the details on whatever you're highlighting or selecting. So this will show us all of our workloads in each individual CSP. And we can even see running processes within those hosts. So here, for example, we see Postgres is running on a specific host, and we can click on it and get more details as well. So let's go ahead and close this out. So within your graph view, you'll have the ability to maneuver. You can zoom in, you can zoom out, whatever suits your fancy, depending on the size of your display. So here, obviously, I've got an AWS instance able to communicate out to Dropbox. If I click on AWS, it's going to break out all the different regions that I have. So here within AWS, I have a region, I have workloads within the US East 2 region. So if I click on that, let's close that out. So if I click on that, that will expand that out to all of the running systems within US East 2. So I have this one, Deepfence POC UI, POC Agent 2, and the directionality of the arrows is the traffic directionality. So here you can see, for example, Deepfence POC Agent 1 is able to communicate out to the internet outbound. Okay. We have DigitalOcean here as another cloud service provider. Microsoft Azure, we can expand that out here in the central US region. That'll give us the metadata on that. If I wanted to click on Deepfence POC UI, you can see all of the processes that are running within that workload in that system. And on the right hand side here is all of the details on this particular system. So CPU utilization, memory. If I want to look into, for example, why is the CPU pegging 99%, that's definitely abnormal. You know, is there a crypto miner running on it or whatever? If the memory is being exhausted, what have you. So here at the top, we give you an immediate view into the overall system resource utilization. Any vulnerabilities that have been discovered in that system since the last scan, any inbound traffic and those port numbers, as well as outbound traffic and those port numbers, and then individual container information, and their actual CPU utilization. So these are all the containers that are running on this host, as well as all the processes. This is more metadata on the host, so things like your kernel version, what distro of Linux is running on this machine, that sort of thing. So yeah, so if we want to, we can click on the individual process and figure out what that's doing. So here, this is the actual command that started that process, which is super cool. You can also look into the actual PID. So what's the actual process ID that's running on that machine? So pretty juicy information, good details. If you're investigating a system or trying to figure out what's running on it or why. Especially a process that you don't recognize. What if there's a process on there like a backdoor or something that's running on there, or SSHD running on a non-standard port like 31337? You have the ability to immediately take a glance at that and find out when that's actually happening. Okay, so we're done here in the overall threat map. Let's go ahead and go into the threat graph. So here within Threat Graph, this is probably one of, I think, the most beneficial areas of ThreatStryker that I enjoy being in. To me, it gives me a bird's eye view of all of the threats across all of our systems, not just vulnerabilities, but also compliance issues. So anything in orange, those are going to be compliance violations from the last compliance scan. And then anything in red is going to be vulnerabilities. So here I can quickly look at either our private cloud, GCP, or Azure, and see that, hey, in our private cloud, we have 101 vulnerabilities there in this particular container. I guess, you know, in total it has 98 vulnerabilities here, and then this container has 3. So if we click on it, we can immediately pull up this information and see that it's vulnerable to log4j. So according to the last scan, and if we sort these by severity, we have the ability to see all of the vulnerabilities that have been scanned, that have been discovered in this machine since the last vulnerability scan. So here, for example, if I want to find out more about this critical vulnerability, this one, let's check out the SQLite vulnerability. So here in this screen, we get all the details on the vulnerability. We can even click on the CVE link and pull up more vulnerability details, which I appreciate, and the actual URLs to the advisory on the vulnerability that was announced. I like this chart because it quickly tells me whether or not this machine is directly reachable from the internet. So we can see from this directionality of these arrows that it's possible to actually reach this host from the internet, and we have these critical vulnerabilities in it. Obviously, I'm going to want to fix those vulnerabilities as soon as humanly possible, especially since it's reachable from the internet. Okay, so to navigate around, whenever you want to close a window, just click the X. You know, we can continue to go in here and look at these other critical vulnerabilities, assign them to be remediated at that point, and we know, you know, based on the severity of those vulnerabilities, which ones we should pay attention to more. All right, so here from the internet, we have 3 cloud service providers. We've got hosts in Azure, GCP, private cloud. We can go in here into the compute instance under Azure, see that there's 61 compliance issues and 3 vulnerabilities. So if we click on the 61 compliance issues, we can see from our compliance scan that there's some compliance violations, things we need to be concerned about, like, guest configuration extensions, disaster recovery is disabled, does not have SSH keys for authentication, so they're using password instead of SSH keys, that sort of thing. We can quickly navigate to the vulnerabilities of this host by clicking on vulnerabilities. And then here again, we've got a list of vulnerabilities since the last scan. Doesn't look like we have any critical vulnerabilities here. We might want to take a look at these high severity vulnerabilities. But again, if it's reachable from the internet, if there's an exploit that's been published for it, and it's critical, meaning that you can do remote code execution or I can get a remote shell. Those are the things that I'm going to probably want to focus on first. We have an Azure storage bucket here with some compliance issues, so I can click on that again. We've got some compliance issues here that ThreatStryker is warning us about. It looks like this particular storage bucket allows network access, allows traffic from all networks, so the policy needs to definitely be hardened, needs to be tightened up. Same thing with our Google Cloud containers. So we've got some compute instances in GCP. Compliance issues with this host, one compliance here, one compliance issue here. So this is the overall view of the threat graph. Again, if we want to change the duration of how far back we want it to show us data from, we can select that here. So the alert screen is basically your attack dashboard. These are the alerts that we're detecting and firing on for any attacks that we detect against your workloads across all of your multi-cloud environments. So here we've currently got a total of 35 alerts across all of our workloads, a prioritized list based on those number of alerts. Here is a quick chart of the number of alerts and the number that's spiked across any particular period of time. Here in the summary is going to be both the summary and attack geo map. So we can look at a map of where we're detecting attacks coming from in a map view. The summary view is basically just, your different charts at what, we're seeing as far as alerts. So here, process anomalies, we've got some exploitation attempts, that sort of thing. The top alert types and traffic analysis paths are going to be in the middle, where you have these hosts that are clearly based on the directionality of these arrows are reachable from the internet, and the number of top CVEs that they are vulnerable to. So the selector on the right will allow us to decide how we want to actually display this data. We can look at the most vulnerable attack paths coming from the internet, paths of direct internet exposure. So these are the hosts that have direct access from the internet, paths with indirect internet exposure, meaning that you have to actually establish a beachhead on a host before you can get to this machine. So in this particular case, if I was an attacker on the internet, I would first have to get a shell on this machine and then pivot laterally over to this machine to get to it. And then the most attack paths, this is going to show you any hosts that are along that attack path are being targeted the most. Here we're going to have a tabular view of all of the alerts that we are generating. So here we can organize by severity. We can also organize by intent, class type, host summary. So if we want to go ahead and take a particular action on this, we can. So, if you think about this, this is very similar to a network detection and response console. So we are actively identifying attacks on these workloads and telling you more about it. So if I click on this particular alert, it'll give me more details. It'll tell me where the IP address from the attack is coming from, the destination IP address, anything regarding what it's actually seeing. So in this particular case, it's the alert is suspicious tracing event process strace is trying to ptrace strace bin ls. So this could actually be a successful exploitation where a payload is actually executing a command like bin ls. And so in this particular case, we've got the container IP. So because this is a process anomaly, meaning a process is doing something that's anomalous that this process probably shouldn't be doing or executing, then it's not going to contain things like a source or destination IP, but in this particular case, it'll give us a trace of the actual commands that it's attempting to run. So let's click on an actual attack attempt. So here's an HTTP request smuggling attempt. So in this particular case, because of the alert type, it's going to give us a source IP. It's going to give us a destination IP. We can click this icon right here to copy it to our clipboard if we want to do further IP tools information or intel gathering on it. The full DNS name, the container name, what we actually saw. And this is the HTTP get or post or whatever request. So here in the bottom right hand corner is a pretty helpful graph. It basically tells us the number of alerts for this particular host over a period of time. So, we have quite a bit, as far as exploitation attempts, there's quite a number of them over the last, few weeks. So, we can quickly glance at this chart and tell whether or not this is a highly targeted host. And maybe if any of the events are for a specific service or protocol and they shouldn't be reachable from the internet, maybe we can quickly use this chart as a glance at like, hey, maybe we should adjust the firewall rules because these services or ports really shouldn't be accessible from the internet. The vulnerability screen is also another area where I spend a lot of time. Within the vulnerability screen, we're going to basically give you a high-level view of all the vulnerabilities that we found since the last scan. So right now, across all of our workloads, all of our assets, we have 362 most exploitable vulnerabilities rated by severity. So critical, high, medium, and low. So this, I can tell you after, doing this for 22 years, doing vulnerability remediation, you really want to focus on those critical vulnerabilities. Anything labeled critical is typically like an RCE, a remote shell, something that you need to give immediate attention to. So those are usually where I start. The top vulnerable running containers. So this is going to list the top most vulnerable containers based on the severity of the vulnerabilities we found, and then the top most vulnerable running hosts. Here are just a breakdown of more charts. So in this particular quadrant, of course, are going to be your critical vulnerabilities, high, medium, and low. Most exploitable vulnerabilities by attack path. So here on the right hand side, we can either change the actual display of the chart we want to see. So by default, it's going to show us the most vulnerable attack paths. We can change it to paths with direct internet exposure or paths with indirect internet exposure. So under the vulnerability scans tab, this is just a breakdown of the different vulnerabilities by uniqueness. And then we do runtime bill of materials. So if you want to dig into this, you can. And here under the table, below all these charts is where I probably spend the most of my time. So we basically give you a ranking, and you can prioritize this however you want, whether by severity of critical to low. From my perspective, I think the most useful thing for me is either by severity and also whether or not there's been a published exploit. Now, the interesting thing here is ThreatStryker does actually give you a link directly to the exploit. In this particular case, it looks like there's a Metasploit Ruby module for this. And this particular vulnerability is, of course, Apache Log4j. So we've all put our time in on this vulnerability to remediate that. So this, again, a score of 10 is going to be critical, attack vectors, network, live connection. So, this will give us the image information of what actual image is vulnerable to this vulnerability. And we want to, of course, get on top of that, especially since it seems to be internet facing. So the second vulnerability here in the list is going to be, again, a completely different vulnerability, but with a rating of severity of critical. I want to definitely get on top of this. It looks like it is actually accessible from the internet. It looks like it's an indirect attack path though. So they would need to get a shell on this machine here and then pivot over to here. However, I do believe that is the host that we just looked at that's vulnerable to Log4j. So we can continue to browse through these. It looks like there's roughly about 37 pages. You can see that the first few pages are actually nothing but critical vulnerabilities. So it looks like the first 5 pages are critical vulnerabilities. So I would definitely try and stop whatever I'm doing and go in here and remediate all of these critical vulnerabilities, especially since a lot of these, again, are accessible from the internet. All right. The secrets page is actually pretty cool. So ThreatStryker has the ability to perform secret scans. Like I said in the intro of this video, we have the ability to actually connect and perform scans of these hosts and look for things like hard-coded secrets, hard-coded API secrets, hard-coded API keys and tokens, hard-coded usernames and passwords, whatever it may be. So the first thing that you see up here is you're going to find a total breakdown of the number of secrets we found. Again, a prioritized listing of the hosts with the most issues. And then here what would you call this? A pie wheel or circle chart of the different findings. So here, for example, there's a medium find here with the shell profile configuration file. It looks like AWS session tokens were found on this host. Username and passwords were found in a URI, a WP config file, that sort of thing. So I would probably, again, focus on these orange ones. And then here are the most recent scans that have run. So we can click on that and get more information on these particular scans and see what those findings were. It looks like a couple of the high ones were found in the most recent one. So, we'll go in here and check this out and make sure that I don't need to yell at a developer or do something to, try and figure out why there's an AWS session token that's been found on this machine. Looks like this one has a username and password in the URI. So you want to look at these details, of course, look for false positives. Ideally, in a perfect world, there would be no false positives, but again, that's the analytic rigor that we need to put into SecOps, right? So going in here, giving you these details, we're telling you everything we're seeing, so you can make that determination on what it is that's going on. Okay. The posture scan, this is basically going to be your scan configurations. Here under AWS, you can see all of the assets here for AWS, Google Cloud, Azure, Kubernetes, Linux hosts. So these are basically where you set up and configure your scans to run. If you want to set up individual workload firewalls, you can do that here from this screen. You can set up a blacklist or a whitelist, depending on what you feel more comfortable with. And there you go, that's it. So thank you very much for spending your time with me. Hopefully this was very valuable to you. It was a quick walkthrough of ThreatStryker. We have a lot more videos that go into way more detail on how to actually set up and configure and run this stuff. I just wanted to give you a quick walkthrough of ThreatStryker, help you better understand the idiosyncratic nuances between ThreatStryker and ThreatMapper and what ThreatStryker looks like. So this was a very cursory walkthrough of that. So thank you so much for spending your time with me, and I'll see you in the next video.